Let's start. So today, our objective will be we are going to understand one more basic concepts with respect to the multi-threading or concurrency. Right? As of
Right,
now, whatever we have studied about this multi-threading or thread, okay, all generally known as a simple thread. But today we are going to understand uh, kind of threads, how many types of thread can be, right?
right,
Right. As of now, we have understand only thread, but never I talk the kind of thread, types of thread. Okay,
right,
we have learned the different approaches, different way you can implement, you can write the thread, right? You can
right,
say ki, hey, this is my code, I want this code run by the new threads. So what are the different way where I can tell, hey Java virtual machine, this is my new code, I am written a particular method, can you run in the separate thread? Okay, the different way to understand how this code can be executed by the thread. Sometime I am writing this code in the thread class as a extension subclass of thread class, or implement runnable, or implement callable, or method reference. Lots of approach we covered to just inform, hey Java virtual machine, can you just run, this is my business logic, this is my code, can in the separate thread, main thread I don't want main thread can do, because main have to some other work I have to plan to do, right?
right.
So today we are going to understand whatever the till now threads we have understand. That's notice all the finally your code is executed by your operating system. Without operating system, nothing will happen, right?
Right,
The actual your code, your instructions, whatever you retains are executed by your operating system thread, known as a OS thread. Finally, here we as a programmer request to Java virtual machine, hey JVM, can you run this code in separate thread? And JVM going to again request operating system. Hey operating system, this is my code. Can you run in a thread? Finally, operating system, okay, you want, let's, I started one thread for your code, and your code is executed by the operating system. Finally, all the code executed in the Java programming language or any programming language is by operating system thread, right?
but so that they at the end they compile it.
Yes. And the
Oh,
end, they cannot compile, they are going to just execute. Our Java virtual machine responsibility to compile and convert my code into the machine level language. This is known as
right,
a initial class. Whenever we started learning Java, say ki Java code written in the source code like English language, they are going to the compile in the byte code, and byte code compile go to the machine language, which
right,
operating system can understand. So whenever operating system Java virtual machine is requesting to, hey operating system, can you run this my code? These codes are automatic converted by your machine language, so that operating system can understand ki what the code written, and so that they can execute line by line. Right?
right,
So till now, all the things, all the programming in with respect to multi-threading, we have done that thread known as your operating system threads, are the different terminology you can either platform thread. What is known as a platform thread? Platform thread. So till now, whatever the approach, we have to understand how we can run our code in a separate thread. All those threads known as a platform thread, right? Here can
right,
say type of thread. Okay, thread. So one type is the platform thread, platform thread, or you can say OS thread. Both are the same meaning, right? Second approach today we are going to known as a virtual thread, or you can say JVM thread, using
Right.
Java thread. You can say Java. Okay. So you can say, in short, in Java language, there are two kind of threads we can write. One is the platform thread, one is the virtual thread. So since JDK 21, this code virtual thread is available for you, right?
Right.
This is released in the Java 21. But these virtual threads are released before the Java 21, like Java 2019, as a preview feature, not as a main feature. But now, from onward, from 21, you download the latest JDK version and you can get this virtual thread concept. So let's first understand what the differences, why this new virtual threads needed as a in the Java ecosystem, right?
Right.
Already we are doing multi-threading since last 25, 30 year, right?
Right.
Java 5, Java started 92, 95, and till now you are 23, right? Already all
Right.
the things we are doing using the OS thread or platform threads, right?
Right.
What the new things we are going to add in the Java ecosystem as a virtual thread? Okay.
Right.
These virtual thread concepts are implemented by a Java language, not in 1 day or 2 days. You can say last 3 or 5 years, they are thinking how we can implement this virtual thread concept. And lots of initially when this project, virtual thread concept is started by the Java teams, given the name as a Fiber, Java Fiber, okay, Fiber. And later part they realized no, some reason now they move this Fiber concept to the virtual thread. So now there is no confusion. Just say there are two kind of threading models in this Java ecosystem. One is the platform thread and one is the virtual thread.
The
Okay.
one we have been practicing, it's called
Yeah.
platform
Till
thread.
now, whatever you practice, all are the by default platform thread.
Okay.
Till now, thread class, completable feature, or you can say executor service, or
It's a
you can
task.
say callable future task. Whatever till now we have covered, all are considered as a your particular method, your particular code is executed by the platform threads, or you can say operating system thread.
Right.
Great. Now we are going to understand the today virtual thread. So virtual threads is not a new concept, first things. And you can, as a Java designer, what they think, uh, they are just going to utilize more capacity of OS thread. Your operating system have a lots of capability, lots of power to do processing, right?
Right.
So currently, what we are doing, we have a one. This is my one task. Okay, in this task, I want to run in a separate thread. So our JVM Java Virtual Machine. What's the hey request? Hey operating system, can you give me just one start one thread where I can execute this my code? So operating system are started one thread for you, right? And you submitting your task here, your task is executed by, right?
Right.
But you notice your operating systems have a limited number of thread creation facility. Here, operating system have a limitation depend upon your memory, depend upon your RAM memory, cache memory, associated memory. How many number of threads we can create at one time, right? So the
Right.
threads are critical resources. Okay, roughly you can consider to creating one thread, most probably 2 MB kind of space required, memory required, right?
Right.
So it's good as of now. There is no problem. But now let's uh, you say, hey, this is my again the task I want to create the in the separate thread. So you again going to request, hey operating system, can you create one more thread for this? And you're going to code here. So finally here, all the threads, whatever you are doing, they are going to one map to the operating system thread, right? Here you
Right.
written a code. You are just requesting, hey operating system, can you run in the thread? So operating system going to create one actual thread and park your code here, and your code is going to run. Till now there is no problem. There is no issue. All work fine as per expected. But let's assume this request is going to increase. I am going to create 1,000 tasks run parallelly, right? That means I'm going to have a JVM going to request, hey operating system, can you just generate 1,000 thread for me in parallelly? Customer want to run 1,000 tasks, right? That means you are going to request the operating system, hey operating system, can you just start 1,000 tasks? They are going to start for you. Might be 1,000 means 1,000 multiplied by 2 MB. 2,000 MB space you required. Might be your laptop, your hardware, server, such capacity available, then you can create, else you can struggle in the problem, right? Because operating
Right.
system say, hey, you cannot create more than task this, right?
Right.
And nowadays, notice millions of requests come on a server, right? So for each request, that's this is the one applications we deployed, and on the server, whenever one request come, I say ki one thread do your work, right? Another request come, another thread. Another request come, another thread. Internally or backend. But let's say
Right.
million of threads one time request come. Can I generate million of thread in the background? Not possible, because each request you are internally going to request operating system generate a new thread.
Right.
So due to that, many times we are going to use the concept of your thread pool. So surely, as of now, if millions of requests come, how are application serving? As of now, application is still serve. But what they decided, they figure out your operating system can maximum support, let's keep 1,000 thread. So internally, we are going to create the 1,000 threads, right?
Mm.
1,000 thread, and 1,000 threads going to works. And once done, then reuse. Once done, that is, that is a concept implemented by your executor service. The executor service say, "Ki I'm not going to crash our operating system. I'm not going to out of memory exception. I have limited our request. I know ki our operating system only support 100 thread. I can only create thread of 100, right?
Right.
And if millions requests come, I take 100 and 100 park here. 100 requests for serve. One done, then I can take the next 100. Okay, next 100. 100 done, then next 100. In this way, currently all our Java enable application handling request, right? So using the thread pool concept, as of now, all the application server are responding many number of requests, right? There is till now there is no problem. So question is that why new virtual thread concept come? It's working as per expected, right? So let's again rethink. So notice this is my one task. Here, Java designer have a figure out some more improvement area, right? The virtual thread is nothing, just one more kind of improvement in our Java multi-threading, right? So what improvement they find? They say, hey, this is the code developer want to run in a multi-threaded. Okay, this is going to request operating system, and operating system create your platform thread for you, platform thread, right? And whatever the code you submitted, the same code copy going copy here, right? And this code going to run. Till now it's okay. What happened here? User have written some statement, maybe type your password, okay, enter your amount, right? Means your application are prompting some user input, right? So whenever your application prompting on the screen types your age, type your password, at that time until user is not typing the value, your operating system threads are waiting, right? Your OS thread, operating system threads are just waiting for your user can give the some output, give the request, right?
Right.
So here what Java designer decided is sometime whenever your applications written some code where your application logically waiting for response, right? Sometime needed. In one business case, I am getting some user profile and I am going to call the microservice. Hey, microservice, can you give me the user profile? Once you get user profile, I'll do something. Until I'm not getting user profile, I cannot proceed, right? So still your application is waiting something, right? Maybe you
Right.
are hitting some database query, and that query is very complex, maybe joining up 10 tables. And whenever you're getting data, your database server takes some minute of time to execute the query, right? So might be your
Right.
code say, I'm going to call the database. And database maybe execute query in some procedure and return some result, right? So might be it would take a millisecond, a minute, or 5 minutes, right? So in this time, your application is still waiting, right? Here our meaning our application waiting means your operating system threads are waiting to complete your job, right?
Right.
So here Java designer think this is the possibility why our very powerful operating systems are waiting just some kind of response. Why not at the times of waiting I can reuse this operating system thread for another work, right?
Right.
So this is the concept where come whenever your thread are going to for wait, maybe blocking call, maybe IO call, maybe sleep, or maybe multiple region where your code are going to wait for response. Maybe database call response, microservice call response, maybe file system call response, right?
Right.
Because in the business logic you have to read data from the third party. Maybe you are reading data from the Microsoft Excel or database or file system or remote server, or you're downloading some image from remote connection problem, network bandwidth issue. Your application sometime really waiting, right?
Right.
So here Java designer think, let's reuse the concept of this waiting thread. So what happened till now, whenever your operating systems start one thread, okay, and until this thread is not completed, this is my Java code. This is my Java code. I requested, hey, JVM, can you give me one thread? They started one thread, and whatever their code, you go copy code in here. Now this thread, no code. This is my code. I have to run one by one. They are going to executing. Let's this line. They are calling some microservice call, and now they are waiting. So your operating system threads are just waiting, right? So here say ki somehow is it possible this operating system thread can free, don't wait. And this is the concept implemented in the virtual thread. Virtual thread say, okay, any code, any code that is running on the operating system platform threads, and if they are going to wait for some response, I am going to swap out this code to the out in the Java code in the sub. Okay, I am going to pull out this code from here to the different space and say now your operating system thread is now free to do next work, right?
Okay.
So whatever they decided, whatever the currently their task doing, which are waiting, just swap out those code from here to the different place in a heap memory, right? And now
Right.
just let this operating system free to work another work, right? So
Right.
now this operating system free, and now maybe I have another task I can submit. Hey, this is a task you can run. So whenever this response will complete it, right? This response will, again we back and submit this task to you, right? So here our objective is that we are going to use operating system thread as possible as, right? Let's keep, we have created three operating system thread, right? Three or
Right.
OS, right? Three operating system thread. Okay. And I have a let's key submitted task one, submitted task two, and submitted task three. I submitted, hey, task one go to run this thread, and task two go to run this thread, and task three go to run this thread. Okay, as of now it's good. And maybe we have a multiple task. This is the one task 4, task 5. I have multiple tasks, right? Okay, in the executor service we have said only 3 threads is serve my purpose, but
Right.
I have submit maybe 100 of job here. So here say कि at a time 3 tasks is going to run on the these 3 threads. Okay, but whenever operating system decide कि any thread business logic are going to wait, our Java code say कि whatever I am given to code you till now, whatever you run, I am going to swap out those code in the subject place in the memory. Okay, and now you are free. Don't our operating system threads wait. Okay, this code is swapped out in the heap memory once, and now this thread free. This thread free, then this thread can start working on the different task. Okay, this is a different work they have to start with. What happened? Let's see, this is the task which are waiting for response. Now they receive the task. Just receive the task. At that time, again, JVM think which threads are free. If any threads free, let's these threads are free. So this work, remaining work, are going to bind to this thread. Hey thread, you can complete the remaining part.
Right.
So the objective of virtual thread is just going to reuse the operating systems as possible as before the multi-threading model. If our code is waiting for response, our operating system also waiting.
Right.
So what we did now say we have saying ki whatever the operating system thread, this thread work whatever the operating system thread, it's work as a carrier thread. They are just carrying some work, and Java thread just actual pure Java code. Okay, whatever number of code you have, okay, you just tell me, hey Java, hey carrier, hey OS thread, can you run this code? It's run. Whenever this thread going for some wait, you just pull out, go to the different place, right? And now thread is free for the new work take, and they are going to again work. If this is the again going to wait something, I am just pull out you. I am not waiting. I am going to take the new task, right? So
Right.
in this way, our operating system threads are always purpose to use. Right, the virtual
Right.
thread is just nothing, just one level of abstraction. Whatever the operating system threads, same way they are using, but they say कि whenever Java developer say I want to create 100 thread, so now previously they are 100 thread going to request to the operating system platform. Now our new implementation, you say hey Java, can you create the 100 virtual thread? They are going to just create 100 virtual thread as a Java application. They are not going to underlying create the request for operating system thread. They are not. Okay, Java system. So okay, you are requesting 100 thread, I can do in the Java level. In the Java side, I create one thread object and for 100. But internally, I know ki all this code I scan, I figure out ki lots of codes are kind of database call, or blocking call, or file calls. So I'm not going to create a request operating system thread to generate 100 thread platform thread. No, they can say from this 100 thread I can only serve the 5. So I can just request the 5, our 5 operating system thread. So they can just create the 5 operating system thread. Okay, and one by one they park here. You do it. If you are waiting, go out. Let's do it. You are waiting, go out. If you are doing, let's do continue. So this is just, you can say, your operating systems thread more utilizations are increase in the form of virtual thread.
So it is not creating 100
No,
virtual.
no, virtual threads are not going to create 100 platform thread. They are create the Java thread. They create
I
the
see.
as a Java 100 thread. There is no problem. But JVM is not going to ask, hey, operating system, create 100 platform thread for me. No. So due
So
to
the way
that,
it works,
huh,
the way it works is like uh, 5 thread works around the clock.
right. Yes, objective is that ki if let's key in our machine, our 8 core machine, so they can generally going to start 8 operating system threads, and 8 operating system thread can serve millions of requests, you can say, because previous model our 8 threads are many times we observe are waiting state generally, maybe due to the file system, maybe blocking call, maybe IO, maybe database call. Generally, whenever you're writing business call, no, in business call, always you are going to interact some party, right? Maybe
Right,
database call, maybe file system read write, maybe microservice call, maybe network call, maybe packet read, and many times our application takes some processing time, right?
right,
Those time our precious operating system threads are just waiting for you. So now what happens is कि whenever any code going to any frequency of millisecond wait, our JVM what say pull out the code from those carrier thread and put the new work for them, right?
right,
So now using the virtual threads, Java enhance as a Java side. Java say कि, and in your side, any number of thread you can request I can create, but I'm not going to create the platform thread. I'm going to create the Java thread or the virtual thread. This is the thread, but they are the code are going to run on the thread, but not a specific one virtual thread. Okay. So here say, hey, Java designer say, okay, I'm going to create a 100 thread, and say, okay, not, but I'm going to 100 virtual thread. Now 100 virtual threads are created by the Java side only. JR, operating system side platform thread. Let's platform thread might be only four are sufficient. They created only one for platform theme, right? So this is OS side only four thread created, but the JVM side Java Virtual Machine can created 100 or 1000 thread. So objective of thread is that ki my code is run by the separate thread, right? Not
right,
the main. So here say ki, sure I am going to run all these 1000 code in a separate thread. It's a guarantee given by the JVM. But I'm not going to create 1000 operating system for you because I'm for one thread task, I'm not going to tight couple to the operating system task. Now, here Java JVM play a role. Say ki one, I'm this is the code you want to run multi-threading. I'm going to mount this code into this thread. This thread to going work. Whenever they find ki you are waiting, I am unmounting your code to the different JVM places and I am free. At the same time, I am going to mounting new code to run here.
right,
Whenever your response you get, might be chance you are again going to mount not a same thread, maybe different platform thread here. So might be case ki one code, one my code, partially this is first portion is completed by the thread 1 and might be second portion is completed by thread 3, might be last portion completed by different. Depend upon the number of mounting, unmounting. Mounting means Java say ki I am going to place your code in a platform thread. That means this is a mounting. Once you are going to wait, I am going to unmount. Unmount means I am just pulling out code from the operating system thread to the JVM, put in my memory, and just waiting. Once you are receive response, I am going to again allocate thread, but not sure that the same thread or any thread. Depend upon which threads available.
right. Video like that.
So this is the concept known as a now you can say platform thread as a carrier threads or simple OS thread, and now all the Java thread you can say this is a simple virtual thread. Virtual threads any code cannot run inside a virtual thread because for running any code need a platform thread. But all the codes are not one to one mapped to the platform threads. Maybe here 1 million thread you can request it, and might be here 10 operating system thread can sufficient to meet all the things. Because this 1000 tasks, yeah, 1 million tasks, all the tasks, if you carefully visualize, they are many times are waiting for response, right? the nature of business logic generally written in the code, always they are not running. They are requesting some data, for getting data, again requesting some data, getting data, then do processing. So many times one business logic take couple of break. So those breaks now reused by the your operating systems thread.
Right.
So these are some terminology, maybe you can say platform threads or virtual threads. Nothing in the sort. In short, whatever the code you are going to run in this form of platform thread or virtual thread, both code are required your platform thread. Without platform thread, you cannot do anything, right? So
Right.
now your Java code previously are tightly one-to-one bound to the your operating system thread, right? Now the what change in the virtual thread? Say no. Your Java code can be bound to the one of operating system thread, but again can be swept out, right? And maybe next time the same code bound to the different thread whenever available, right? Maybe if you are again going to waiting, again you swap out means unmount, and next time maybe different operating system thread you can go to again bound. So this is bound are the terminology used by the Java documentation, mounting, unmounting. Mount. Mount means Java code are going to mount in the platform threads. Whenever your business logic are going to wait for response, Java say, okay, you are waiting. I am going to again unmount. Unmount means I am going to again pull out your code from the platform thread to the inside your Java heap memory. Okay. And once you are ready, again I am going to again mount to you to the any carrier thread, maybe platform thread, whatever the at that time available. So you can say just different way of implementing multi-threading. And nowadays, Java claiming on your laptop, you can generate any number of threads as you want because you requesting create thread. I am creating inside the Java memory. I'm not going to hampering the operating system, right? The operating system have a critical resources. I'm not going to direct one-to-one map, but I'm guarantee whatever you are submitting, your task is run by the separate thread to this algorithm, reusing the operating system thread. Till now, any confusion, doubt with respect to what is virtual thread? Virtual thread is pure Java enabled thread. Okay, or you can say pure Java enabled thread. But this code are going to run required actually platform thread. Okay, platform thread. So platform thread always needed, but this is not one-to-one direct coupling between your platform thread and your Java thread. Your one
Right.
Java thread can be run by two or three platform thread, right? Maybe first time partially done by here, next time done by here, next time done by here. So one thread, one partially code can be executed with a multiple platform thread. Or might be if your code is business logic very simple, there is no any waiting, there is no blocking. Might be one thread can completely complete your jobs and now it's free, right? So virtual thread is just one kind of a new enhancement in the Java multi-threading ecosystem, right?
Right.
So this is the theory part, but this is very interesting part. In the real life, always we are doing, right? Many times whenever in our office or your company any employees are doing something, okay, and I say okay, hey, this is my employee number one and doing something, okay, and now they are blocked for some card, some user story. So I'm not saying hey, user, you can also block. I'm say okay, halt this work for some time, let's you do the next work, right? Once this hurdle risks are done, then you can again come and do, maybe might be different user can continue this work, right? So similar kind of a analogy which we are using in our real life are implemented by the Java in operating system as well, right? So this is not kind of a new things, just a different way of reusing the platform thread. So before virtual thread, we are never talk as a platform thread. Always say thread, thread, thread. Yeah, OS thread. But now, whenever the new concept come virtual thread, then always we talk about the platform thread. Platform thread means actual operating system threads. Virtual
Right.
thread means the Java enables just code, right? So question,
Right.
how we can create the virtual thread? Okay. So for
Yeah.
a very good thing uh, given or done by the Java designer, I am very very happy. They are not creating any new kind of a class. Again, using the same thread class. Good part for multi-threading, they are not going to create any new virtual thread class like a things. They say कि whatever the existing thread class, whatever the developer till last 30 30 years they are doing, say multi-threading, the same class still they are doing. There is no change. The thread class again we are going to use. Okay, just they are added one two more method. Okay, कि you want to create virtual thread, or if you're not, this by default they are going to the platform thread, right?
Right.
So notice here you cannot say कि virtual threads are platform thread. Virtual thread is very faster than the platform thread. No, there is not the purpose of fastest or slowness, because underlying both are the operating system threads. Both are the
Right.
same performance. Our here objective now, we are going to take more user requests at the same time, not awaiting millions of requests we can serve at the same times, right? Millions of
Right.
threads we can create in our code itself. Don't worry for that, because you are not going to request underlaid operating system create the millions of threads, because in our operating system hardware have a limitation, right? But
Right.
Java which in Java code have a no limitation. You can make a loop 10 time yeah 100 time yeah 1,000 time, because we are running in the logical loop, right? Code. But whenever you're talking about the operating system physically, they allocated one RAM memory for you, and requesting your instruction can be executed, right? So that is the
Right.
challenges of your hardware operating system. Operating system cannot allow to, hey user, can generate million thread in one operating system, because we have a very limited memory nowadays. In my operating system, have a maybe 32 GB RAM or something, maybe 100 GB. How many times you can, how many space you have? Limited space, right? Due to our motherboard capacity, due to the bus capacity, due to the read write capacity of hardware, right? So
Right.
surely our hardware have a limitation, but software have a not more such more limitation, right? So here JVM say कि I'm a software side, pure software side. I am assuming कि any user can request millions. I am going to serve each request at the same time. Purpose of this multi-threading that कि I am our Java-based application going to entertain all the requests as a separate thread. Okay, don't consider to just pool of thread, so that each users are feeling, hey, oh, my request is going to the serve by the application, not say कि just wait couple of time you are getting a response, right? So objective is that our applications become more responsive. Each users are going to entertained by the separate thread, right? Means ki virtual thread,
Right.
correct? So good part, Java we have to again use the sim thread class. Okay? So they are not implemented in a new separate class for virtual thread. Just added one more method. Dot. Notice we have a before like a starting thread. Now we have a virtual thread or start virtual thread. Just give one method. Start virtual thread, and here whatever the code you have. Here say let's give this is my task. Static void my task. Okay,
Right.
my task executed by. thread. Okay. So this is the whatever the task business logic. Just you can pass here my task. Now here you say I'm going to start new virtual thread. So here your task is not directly bound to one specific hardware OS thread. Your task is mount maybe any number of available operating systems. Maybe if this is my business logic will take couple of minutes to proceed, there might be some portion of code is executed by the platform thread 1, sometime platform thread 2, and finally maybe mix up, right? But
Right.
implementation perspective very simple. Just say hey thread dot start and done. This is the simplest one new method there ready to start the virtual thread, and it's done, right? So for creating virtual threads, Java designer have given a okay. So I'm not getting output, right? So might be your main is closed. That's out. 1 minute. So let me uh, uh, take the variable. They return the thread object, and here say I'm just going to thread dot join so that it will complete. Okay, then main close, right? Join
Right.
and say out main, and, and is okay. Fine. Again, same method throwing exceptions. So from the programming perspective, there is no major changes. Just using the same join method, each and everything. And you run. So join methods, I'm saying, hey, this thread complete, then main going to the close, right? Executed by.
Hmm?
So this is the one way,
আমরা ভুলে গেছি এটা।
and
উনিই থাক।
different way we can say
হ্যাঁ?
another method like a thread dot. You can say off virtual. There, notice there are two kind of option now we have it: off virtual or off platform. So now while the creating thread class, you have option. You want to create platform threads or you want to virtual threads. Now uh, Java given option to you. Before there is no any option, no platform thread, no virtual thread, only OS thread. So now we have a two option: of virtual thread. You can say of virtual threads, and maybe here you can say pass the task, runnable task or unable, whatever the task like you pass here. Let's see same task I want to pass. This is my task and take variable, and now your thread, and this is the way you can say thread one dot join and run. So so we have a two option. What you can say directly start virtual threads, or you can say first say ki, I'm going to create virtual thread and then going to start whatever the task I pass here.
Oh, I
So
see. Two way.
so one option is start directly here. You're going to start here. Say no, I'm going to start. I'm going to start, right?
Mm-hmm.
And even more option here. Say uh, thread class of virtual, and just you check. This is the another option. Unstarted and started. Here you can pass started, and after say unstarted. Unstarted means I'm just going to create my sample task, but this is not started. So notice here, this is thread class you have, and here hey thread you can start. Manually you can do. Similar like here, right? Here you are going to again start. Here also automatic started. Automatic started. Here say no. Here I am going to create the task, virtual thread task, but later part I am going to start. Maybe I can start here.
Right.
And after start, I can say that I'm waiting for the join, right? So they just added some more method for us, right? So that we can, if developer want to create virtual threads, just use off virtual as a factory method. Notice they are executed. And similarly, sometimes you say here,
So we need to start first
uh,
and then join.
well, yes, whenever thread start here. Purpose is that ki, or I'm going to main application until going to not close until this is not completed, right? So I'm saying
Mm.
just joining this thread until going to the complete job.
Right, right. Okay.
And here is the, let's just explore off. Both have off. There you have now both options: off virtual thread or platform thread. Or platform thing like, look like a previously whatever you did. Off virtual means you are going to create virtual thread. Now let's create the simply variable here. Now notice that this is the off virtual is the one kind of a thread builder. So nothing Java designer say ki whatever the thread class, I am just added one method of virtual, and internally they are going to building the your virtual thread. And after virtual thread, whatever do you want to do, maybe set some start or unstart web option. You want to set name or something. You have some factory method. So you want to say, hey, I am going to start or unstart. Just I want to test set the task. What the task you want to run, right?
Right,
Here I have a multiple option. Maybe I want to unstarted. This is my simple task I want to run, right? And after that, here say once build the build this task, and after that say, hey, now my thread is building done, and now after this, hey, now I can go to start manually. I can go to start, right? So all the functions are the same as previously. There is nothing new, but yeah, the concept wise internally they are a different way. But programmer perspective, writer perspective, like existing multi-threading, same work and here. All the concepts are work same as here. This internally implementation approach, internally all the things done by the library side by itself, right? Here you don't think how I'm going to mounting code, unmounting code, how requesting operating system thread. That are all the theory parts already implemented inside the virtual thread concept, right? So now we have nothing else special. Just now we have options. You are going to start as a virtual threads or as a platform threads, right? So generally, this is the way you can start virtual thread. Or similarly, always say whenever you are doing the multi-threadings, please use the executor service, right? So here also our executor service have a added one new method, executor service dot new dot. Here they
Hmm?
added one notice here, virtual thread. Notice new virtual thread pool, right? So now here, if you are using the executor service, someone say how I can create virtual thread. So you can use this concept, the new virtual thread pool, right? And now here you can use dot submit, whatever the method you want to submit. Okay, same task you want to submit them, and good option you can write in a, okay. And after that you can say we have an option. You can say, hey, now done. Let's shut down the, okay. A good option instead of shut down, and directly you can say, hey, try. Okay, best option try, and here open and here I close. Okay, and in this way you can say using the executor service also we can start virtual thread. Just you change your factory name, new virtual for thread. Okay,
Right,
now it is executed. So here uh, one thing please be remember, in the case of executor service previously, we are saying ki create the pool of thread, right? Pool of thread, five pool, or two pools, or three pool, right? And let's here say ki four pool. Initially, four platform threads are created by the Java library. And now here in the submit method, I can submit. I can submit 10 tasks, right? I can submit 10 tasks. The 10 tasks is done by the maybe this, maybe this, maybe this, maybe this, and maybe this, right? Depend upon the available. So here, whenever virtual thread concept come, Java designer suggest don't use thread pool. Okay, don't use the pool for the virtual thread. Platform threads make sense, right? Platform thread is the operating system thread. You can pull them and reuse. It's okay. But in the case of virtual thread, there is a no any make sense to making pool of virtual thread. Virtual thread is not actually thread, right? This is a thread inside the JVM. So why are you making the pool of JVM thread? Just don't do. So due to that, in Executors framework, they have written this new code, new virtual thread per task executor. Notice for each task, whatever the number of I'm going to submit here 10 times, right? I'm submit 10 times. I'm submitted 10 times here, but each 10 time, notice they are just going to create one virtual thread for each task, because virtual thread is not a your platform thread. Internally they are going to use, but don't take care. Here just use this way. Now your code is executed by multiple times. The same code is executed by the separate thread, right?
Right.
Is it clear?
So virtual thread do not create more thread.
No. Virtual threads are just created more thread as number of thread you requesting inside the only virtual machine, JVM side only, Java
Okay,
side.
okay. I see, I see, I
They
see.
are not going to create your operating system thread for each request. Number of submit,
Okay.
number of submit, number of submit. They are not going to create new operating system thread. No, they are just going to create number of your Java thread, Java thread, Java thread.
Right,
Millions of Java thread you can create, but millions of operating system thread we cannot create, because here have a hardware limitation, right?
right, right, right,
So now preferable way always you can use the executor service and use the new kind of a virtual thread, new virtual thread per task executor,
right.
right? So this is the one or two kinds of guidelines. First guidelines, uh, never do pool of virtual thread, right? Pool of virtual thread, because there is no make sense, because there is no make sense, because virtual thread means a Java enabled thread. Why are you pooling? Pool means this is a costly resources, then you can reuse. So here say Java say never do pool of virtual threads. And second guidelines, you notice I'm saying ki, now your operating system thread become a carrier thread like a platform threads. Here our code can be mounted, means ki after doing, and after some time again say unmounted, right? Unmounted, for some waiting, for some locking. But there are some kind of challenges in this virtual thread. You notice in the last couple of class back, whenever you use the synchronized keyword, right?
Right,
Synchronized keyword to make a ensure that this is the code is executed by the only one thread at a time, right?
right,
Whenever new threads come, they are going to the wait. New threads come, going to the wait. This is the kind of a synchronized keyword locking code. So here new threads go and wait. New threads go and wait. New threads go and wait. That means here your all threads are pre-system threads are waiting. So in this case, logically, this code must be unmounted because your threads are waiting, right? So
right,
Java suggests if your code is written with the synchronized keyword, I am not able to unmount them. This is the problem, because this code synchronized keyword code written in the C language. Okay,
right,
and C language is the operating system code, right? So general guidelines, uh, if possible, if possible, uh, don't use synchronized keyword. Synchronized keyword. Okay, synchronized keyword. Question then what I can do? Alternative you have use reintrent lock, right? Lock. Already we have a lock interface. You can use the lock interface. The same purpose you can achieve here, right? So preferable way you can use a reintrent lock. So this is the two kind of many more, but this is the as a developer perspective, we have to always take care if we are going to use the virtual thread concept. Don't use the concept of pool of thread, and even avoid using the synchronized keyword. Let's try to use the lock interface, right?
right.
and let's use the lock interface for locking. Okay, so these are the some guidelines till now in this Java virtual thread. Whatever the till now we have understand about the virtual thread concept, all is the same as for the virtual thread. There is a new no difference. This is just different way you can create the thread, right?
Right.
Maybe you can try here. Maybe in a loop you can create the virtual number of thousands, 10,000 or million threads. It works, right? And if you try to same create the platform threads, it will sometime you're getting the out of stack, out of memory error problem, right? But
Right.
those things is here you can easily we can avoid using the virtual thread. The virtual threads from the developer perspective, from code perspective, nothing more changes, just new keyword of virtual and that is start, right? And rest all the multi-threading concept work. But behind the hood, they drastically they are change the implementation of your one code bound to the one operating system threads.
Right.
So internally, previously what happened, your this one code are directly going to the bound one operating system thread, right? If one your
Right.
code waiting, your operating system thread also waiting, right? Now this tight coupling your code to the operating system threads are going to make a flexible. Now your code is not tightly coupled to the your operating system threads. Your code is still coupled when they are running. Whenever they are going to wait, they are you are going to swap out here. And now our OS thread is free to do the next work. Whenever you are getting response, you can might be get the different operating system thread and go run again, right? All the major things implementation are taken care by inside library itself. For developer perspective, feel feel free, just use maybe platform thread or just use the virtual threads.
Right.
Only benefit in virtual threads, you can create any number of threads as you want. So here you can increase your application throughput. You are not telling, hey customer, please wait, my all resources are free, right? Occupied, right?
Right.
So here we using the concept of virtual thread, our applications number of requests serving going to increase. We are not saying anyone, hey wait, all user requests are going to create the separate virtual thread. Millions of user, millions of virtual thread I can created. All are working independently parallelly.
Right.
So this is the major benefits of a virtual threads in the case of huge number of requests when you want to process. Their time virtual threads are very helping. But in the case of 10, 20, 100, 10 job, 20 job, platform thread is sufficient for you, right? So these virtual threads are highly more responsive, more useful, where your applications are highly used. Number of requests or number of requests, concurrent requests coming more. In those cases, preferable way always you are going to create using the virtual thread. So most probably now this JDK 21, this is the released virtual JDK, and all the coming all the servers, maybe a server that's are written in the Java language, they are going to previously they are using the platform threads and using the thread pool concept. Now most probably all the operating system OS, yeah, servers are going to implemented this concept about the virtual threads. They are very used in this all the framework designer, all the server designers who are building the server, right? So this API is very help for the bigger player, right? Good.
Yeah.
Till now, any confusion? So here you can say now you can create virtual thread using the thread class API of virtual method, or you can use the executor service, new virtual thread per task executor.
Yeah, yeah. It's I
Right.
using the existing class name,
Yeah. So
uh,
before,
either using
yeah,
executor service
uh, you
or
have a method now of virtual thread. You can create the virtual thread, or you can say
right.
thread. Uh, Similarly, if you want to platform thread, you can also say off platform. The both you have an option now. Both option given to the Java designer to the developer. Developer decide you are going to create virtual thread or you are going to platform threads. At least
Mm,
now, our Java developer know ki this is the platform thread or this is the virtual thread. Before this, there is no such option of virtual or platform. By default, each and every thread considered as a virtual thread, right? Good part.
yes,
So these are the very not from the perspective the language changes, but the very useful in the case of our increasing application throughput, high performance application, right?
right.
Let's practice of these virtual threads and the platform thread both, and all the things we have studied related to multi-threading couple of classes, more than 4 or 5 classes. All the concepts work same for the virtual thread. There is no new thing, right? All
Right.
concept works, right?
Right.
Only these two things please avoid. Don't do the pull up thread, virtual thread, and similarly, don't use the synchronize keyword if possible. Alternative, you can use the lock interface.
Okay.
And
Okay. I see. I see. Yeah.
all the things of multi-threadings you can use here. You
Right.
can callable interface, you can use
Only these
reference
two.
interface, you can
Only
use method reference. The number of this is the given the flavor. Whatever the number of thread you want to create, you can do. Maybe one, maybe 100, maybe 1,000, maybe 10,000.
right.
But whenever doing the same thing here, after available memory space, you have a boundary. Number of memory, RAM memory in your system have accordingly the number of platform thread you can create, right? But here,
Right.
almost no limitation you can say. Purpose here, virtual thread per user per request, right?
Right.
For each request, I'm going to create new virtual thread. That's the thread. That's for the day. Anything you want.
Yeah. That's good for today.
Okay, great. Let's do practice. Any doubt, we can correct. Okay.
Sure. Thank
Thank
you. Bye.